Okay, so your exam is going to include section 2.3, linear equations, but the 2.3 type questions on the exam are going to be ones that are a little bit easier. And like you had the 2.3 exercises due today. Okay, and those were linear equations where you had to find integrating factors, and then you have this new section 2.3 assignment that's due next week. So the section 2.3 problems on the exam are going to be easier ones where the first set of exercises that you did today should be adequate so you could do those problems. Okay, so I want to do a harder problem that would be helpful for next week's assignment, and that's what this example is. So take a moment to copy this example down. Okay, so we want to find the general solution of this differential equation here. Okay, and is this a linear differential equation? Is this differential equation linear?
Yes, it is.
That's right, Michael. It is linear. What's the order of the differential equation?
First order.
First order, that's right, Thomas. And is it possible to separate the variables?
Yes.
Okay. Can you hear me okay, my audio? Oh, it's okay. Thomas's audio. So Thomas, you must have some kind of something going on there that's causing that static. I don't know what it is. I'm not an expert on this, but but now I don't. All right. So all right, is my voice coming through okay?
Yeah, you sound good.
Okay, good. All right, thank you. Okay, Michael, you have to probably log back in, log out and come back in because folks are hearing me okay. So if you're not, you just have, I don't know, I don't know what the issue is, but I would try logging out and coming back in. Well, I don't know. There could be another issue. We can talk after class about it, but I think everybody's hearing me okay. So except for you, and maybe we can figure out what's going on there. Okay, so let's go ahead and we're going to use the integrating factor technique because this differential equation is not separable. It's not separable. So there were 4 steps to the integrating factor technique, as you recall. There are 4 steps. The first step is to get the equation, the differential equation, in standard form. Okay, and that's what we're doing here. Okay, so take a moment up to here. Let me know if you have any questions.
Professor Greg, can you explain why it's not separable, please? I don't know if you can hear me right or with static.
All right, sorry. It's not separable because there's no way you can. Thank you, Thomas. There's no way you can get the y variables on one side and the x variables on the other side. Okay, no way. And thank you, Andre. So that's why, Thomas. I mean, you try to separate the variables, and you won't. I don't think you'll be able to separate the variables. Well, the reason is, let's see, Thomas is asking, is that because of the term XY? Yeah, that's a problem. That's a problem. If this term weren't here, then you could separate, yeah, then that's right, Thomas, then you could separate the variables, but that term's there. So you know. All right, Thomas? All right, very good, excellent. Okay, so we divide by the 1 plus x, okay, we divide by 1 plus x everywhere. And incidentally, we know based off of that, that, you know, x cannot equal what value? X cannot equal -1. Okay, so it's, you know, got to keep these, thank you, good, Andre, good, Kathia. Got to keep these things in mind, you know. Now step two, we're going to find the integrating factor. Okay, the integrating factor is, excellent, Michael, excellent, thank you. So the integrating factor is equal to e of the integral of px dx. Okay, and so this is what we have. And then I'm going to factor out the negative sign. But I have to integrate this integral. And really what I'm doing here is reviewing this problem's going to review some integration techniques. So, you know, of course, in this course, we assume that you know integration techniques, integration by parts, substitution, partial fractions. And of course, on the exam, there are going to be problems where you have to show your integration and show your work. So you know, it is important to be able to do this, do integration. And anyway, how do we handle this problem? We have the integral of x divided by 1 plus x. Well, here's what you do. You take x and divide it by 1 plus x. You take x and divide it by 1 plus x. And x is the highest power there, the highest order term. And so x goes into x one time, and 1 times 1 plus x is x plus 1. And you subtract x plus 1 from x, and you will get a -1. So x over 1 plus x will equal 1 over 1 minus x. Okay. It's no different. It's no different than if you were to take 3, you know, and divide it into 8. 3 into 8 goes 2 times. 2 times 3 is 6. 8 minus 6 is 2. Okay, so 8 thirds is equal to 2, which is your quotient, plus the remainder, which is 2 thirds. It's no different. This process here this process here, x over 1 plus x equals 1 minus 1 over 1 plus x, is no different than what you learned in grade school. It's just you're doing it with expressions, with variables. Are there any questions up to here? How many recall that from Calculus 2, learning how to do that? Okay, all right. Well, sometimes what happens is in a course, you learn something maybe you haven't seen, but it is normally covered. But hey, you know, it's in the Calculus 2 book. But I did long division. That's right, Matthew. I did long division to simplify the fraction because I have to find the integral of x over 1 plus x. And so I do long division. That's what happened. Okay, Antonio? All right. All right, so now let's go to the next page here. Well, that's right. So now I'm going to go to the next page, and I got to find my integrating factor, but first let me find the integral. Let me find what this equals, the negative integral of x over 1 plus x dx. Okay, so we established that that can be, by long division, that can be written as negative integral of 1 minus 1 over x plus 1. And the difference of those integral, the integral of the difference is the difference of these integrals. And so this gets you here. And now at this stage, I'm noting that x is greater than negative 1. So that normally the antiderivative of 1 over x plus 1 is the log of the absolute value of x plus 1. But what I'm doing is I'm leaving the absolute values off. But if I do that, if I leave those absolute values off, that means that the x plus 1 has to be positive. And that's only going to happen if x is greater than negative 1. Hold on here. The minus sign be the purple circle. All right, hold on. I'm distributing the minus. Oh, hold on. Let me see here. Oh, good catch, Matthew. What Matthew's saying is I have an error here. This should be a plus. Thank you, Matthew. Distributing the minus through. This should be a plus here. Good catch on that. All right. Are there any other questions? Okay. Well, then now we can get our integrating factor, because the integrating factor is e to the power of that negative integral, but we know what that integral is, right? We know what it is. And by the way, I should have equal signs here, right? I should have equal signs. And I'm doing this problem because it's going to come up in that new homework that's due next week. And, you know, I'm hopeful this guidance is helpful. Okay, so now what do we have going on here? Well, you have the integral. If you have the integral of a plus b, that equals, I'm sorry, if you have e to the a plus b power, that equals e to the a times e to the b power. Okay, so what I do is, let me see here. I guess I wrote a step down twice, didn't I? No problem. We can go from here to here. And then this is going to be your integrating factor. How many are thinking, man, I maybe would have gotten that if Dr. Duty hadn't shown us? How many might be thinking that? I think you would have gotten it. But how many are helpful that how many feel good that we're covering this problem? All right, you got a quick thumbs up from Christopher and Kathia and Ann. Okay, great. Antonio, Zachary, excellent. My goal is for you to be successful. Everything I do here is for you to be successful. Please always remember that. Thank you, Matthew. Thank you, Andre. Thank you, Thomas. All right, so now we have the integrating factor. Thank you, Thomas. Thank you, Andrea. Thank you, Christopher. Okay, now we have our integrating factor, and what do we do with this integrating factor?
Don't you do the multiplication and all that?
That's right, Christopher. We multiply it through the standard form of the differential equation.
Yep.
So if you're ready, I'll go to the next page. Are there any questions? Okay,
Professor?
let's go. Yes,
Professor?
Michael.
Why did you drop the absolute value sign?
Well, so you're right. Normally I can't just drop an absolute value sign, right? The antiderivative of 1 over x plus 1 is equal to the log of the absolute value of x plus 1. But what I'm doing is I'm specifying, let's suppose x is greater than -1. If I do that, then I can drop the absolute value sign because x plus 1 would be positive.
But
Okay.
is that not going to prevent some? Is that not going to exclude some other solutions when
It would exclude some solutions, but in the context of this problem, like for the problems in your homework, they drop the absolute values, like when they get the log, and I suppose it's just to make life a little easier for you all. But they drop the absolute values. But if you do that, then you have restrictions on your solution. So you're absolutely right on that. But it's okay. You know, I mean, it's okay. I mean, you know, if you had an initial value problem, you'd have to have, like, you couldn't do an initial value problem like this. Like if you had an initial value y of -3 = 4, you couldn't do that because x has to be greater than -1. But you could do an initial value problem where y of +3 = 4, because there x is greater than -1. Okay, good. All right, let's keep rolling on here. So now step 3, I multiply through the integrating factor through the standard form of the differential equation. Right, this is my integrating factor, and you always want to simplify that integrating factor before you multiply it through the differential equation. You always want to do that. Really, and it's really it's really to make this, dropping the absolute value is to make it makes the solution easier, and because you don't have to worry about dealing with the absolute value, so it makes the solution easier. And then, but the trade-off is you have a restriction on where your solution would work. So really, it's like for WebAssign why it's doing that. Okay, good question. All right, excellent. Okay, So here we are. Here we are. Now I do a little simplifying. You want to simplify, and that gets me down to this step. And it turns out that the left side of this differential equation is equal to the derivative of the product of these two functions. The one function being x plus 1 times e to the negative x, the other function being y. And, you know, at first, you know, and I worked through this problem just like a student would. At first, when I saw that, I thought, wow, you know, I'm not sure about that. Did I have an error? But it checks out. It does check out. If you differentiate this product here, you will get this expression on the left. Okay. So now, you know, we're into step 4 where we're going to integrate both sides of the differential equation. And that's what we do here. But on the left side, the integral of a derivative just gives us the function back that we're taking the derivative of. Okay, give you a moment to catch up here. Are there any questions?
Yes, I do, Professor, but it's not on this page, but the previous one. If you want to wait until we finish the exercise.
Yeah.
Okay.
Yeah. Can you verbally tell me what maybe is it something I can answer verbally?
It's on step number 2. It's
Okay.
Yeah. Let me see. It's when we. Hold on. Give me just a minute.
Hold on. I'll go back a page.
Yeah.
Maybe you can take the mouse.
Excuse me. The pencil? Can I get the pencil?
Yeah. You can get it.
Yeah. This. I am not sure about this step over here. I know. Is that a log property that is happening here?
Well, we established that I'm sorry, there should be equals here, right? There should be equals here.
Okay.
So the integral of x over 1 plus x dx. Okay, the negative integral of x over 1 plus x dx, okay, is equal to negative x plus the log of x plus 1. So negative x plus the log of x plus 1 is what I have here. See, I'm just...
Yes. Okay, I got that. Okay.
Okay, very good, very good. All right, so now we're here, and we have to compute these two integrals. We don't need a computer to do this. We don't need a computer to do these two integrals. I would want to see this on an exam, this work. You know, I'm going to give you, for each part of the exam, you're going to, I mean, now this is not, what I'm trying to say is, well, you do have some integration, right, on this exam, but I mean, what do you have to, what procedure do you have to do here? What procedure do you have to do to integrate both of these? Substitution, partial fractions, integration by parts. How do you do these two integrals? Integrate by parts. Going to do integration by parts. That's how you do it. Okay. Now, the second integral just takes one integration by parts. But the first integral, you have to integrate by parts how many times? And I know you've seen this in calculus too. Twice. That's right. So, okay. I go to the next page. And now what I'm going to do, let's just, I have it here in the recording. Well, all right, so let u equal x. Andrea, you did get it. That's right. Excellent. U equals x, dv equals e negative x dx. You work it out, and your integral is going to equal this integral here. Okay, that's so integrating by parts one time. So on the exam, I'm going to want to see, like for integration by parts problem, I want to see you show integration by parts. Okay, I need to see that you understand how to do your calculus. Okay, now maybe Professor X that you had doesn't care about that, but I do. I do. It's important. Sometimes we use computers to help us. It's true. They're great. But this is something you can do. All right. No problem, Michael. We will. This is going to be on the recording. Okay. Now let's do the other integral then. The other integral. Okay. Are there any questions on this? Who's feeling comfortable? Thank you, Christopher. I understand, Matthew. It's a lot of work, but that's what makes it great, right? You ever see the League of Their Own with the baseball players, the female baseball players, and one of them says, "This is so hard," you know, and the coach says, "But that's what makes it great," you know. And so, all right, Andre, I'll take that. Great, but scary. Now the other integral, you have to do integration by parts twice. Okay, and so I have this shown out in the recording. Where, well, I mean, it's shown here. I do integration by parts the first time, and then I'm going to get this. And what I want to do is I want to kind of, well, all right, that's fine. That's fine. I do integration by parts by once, and I get this result. No problem. And then I simplify things a little bit. And what happens is this integral comes up again, right? But we already know the antiderivative of x times e to the negative x from the previous page. So I can just substitute that in. And so that gets us this integral here. Okay, are there any questions? How many remember doing integration by parts twice in Calculus 2? It's how many has it been a little while since I've had to do that? Okay, all right. All right. So, well, now we move on, and recall, I understand, Thomas, and that's why I'm reviewing it with you. I understand. That's so. Recall that originally, right? Going back here, we had this was our equation, and we needed to solve these integrals. And I've done that. So now I can substitute in my antiderivatives for these two integrals. And that's what we have on the last page. Here's the one integral. Here's the other integral. And then you have a constant. And now you can solve for y and simplify your answer. And finally you get to the answer.
I gotta say, it's a long process.
Well, Thomas, I wanted to do kind of one of the hardest ones with you, because then you'd be a little more comfortable when you encounter it on the homework. You're not going to encounter this. Well, I want to be careful. You're not going to have a problem in section 2.3 where you have to do this much integration, but on the next exam you could, but not on this exam. The section 2.3 questions on the exam 1 are going to be. I want to be careful what I say. You always have to do integration, right? But they'll be simpler than this one. Okay. If you're comfortable with your first assignment from section 2.3, you'll be comfortable with the section 2.3 questions on your first exam. Okay, but I think, Thomas, you're kind of amazed. I like that. You say this like you're amazed, and I like that. I like that because it is amazing what we can do, right? It is amazing what we can do. All right, so I think, Paige, I've answered your question, and all right, very good, very good.
I have a quick question, Professor.
Yes, Christopher.
So I know that you're posting the class recordings. Is it possible for you to also post? Oops, what am I doing? Is it possible for you to also post your PDF files of your work onto Blackboard?
I prefer to do the recordings. I prefer to do the recordings, at least for now, Christopher, because the what's on the PDF is in the recording, there is proprietary things too. Not that I'm not saying hold on, I'm not saying you're going to go and sell my notes. Please, I don't mean that. I don't mean that at all. Let me stop the recording here.